I read the statement wrong. Let me read it again. Suppose 30 people are in a room. What is the probability that 2 of them share the same birthday? Ignore the year of birth. So we're just looking at the day. And so we have a table of values here. And so if I have 0 people in the room, they have pretty much 0 probability of sharing a birthday. That's common sense. If I have 5 people in the room, it's 0.027. So if this is just a table of values where the first column, or the X value, represents the number of people in the room, and then the Y column represents the percentage of people that will share a birthday. So when you get 70 people in a room, you got a pretty good shot of 2 of them sharing a birthday.
Yeah.
All right. Now, what we want to know is the behavior of this mathematical relationship. Here's the graph. So way up here is like 0.97, 0.98. So at some point in time, the probability stops increasing, kind of levels off. And that just makes sense because you can only get so close to 100%. And when you have nobody in the room, you have no one to share the birthday with, right? So you have this change in probabilities, graphically speaking, okay?
Yes.
So now what they asked us, let's try to make sense of it. It says, what is the probability that 2 of them share the same birthday? Well, if we have 30 people in the room, we have 0.76. Now, the textbook says in the solution, and I'm just going to read it word for word, so if you guys could read along, that'd be helpful. It says, it may surprise you to learn that the probability of a shared birthday among 30 people is at least 0.706, 70.6%. Well above 2/3. In fact, if we assume no one day is more likely to be a birthday than another, then the probabilities in Table 1 are not hard to determine. Okay? Now, what they've gone in Table 2, they've calculated the slope of the tangent line at the midpoint. So the midpoint between 0 and 5, in other words, what they did is they calculated the slope using these 2 points. Okay? And so they say, well, at about 2.5, we approximate that the slope is blah, 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 blah. And so what we want to look at is, when is the slope the steepest? Well, it just so happens right at 22.5 and 17.5.
Yep.
Okay? Now, it didn't ask us any of that. You know, I mean, truthfully, you could have answered the question just based on this information. So why did they show us the extra stuff? Well, it says that, notice that the probabilities grow slower at first, and then they grow faster, and then they become more slope once you get past x equals 45. At which x are they growing faster? To answer this question, we need to graph the derivative. And then it shows you how it calculates the various approximations. So I'm going to turn the page, and now if we graph the derivative, and I haven't quite shown you how to, well, I have, but we'll show you the equation. This is the graph of the derivative. So the y value of the derivative represents the rate of change. So here we have a slow rate of change because we're close to 0. Here we have an increase in the rate of change, increase in the rate of change, increase. This is our greatest increase with regards to the rate of change because this is our highest y value on the graph of the derivative, which occurs at about just before 20. Just before 20 people. Now, we could see that in the table of values, that at 17.5 we have the greatest slope, and at 22.5 we have that same slope of 0.0316. But that's completely different than the original graph, right?
Right.
That's a point of inflection right here.
Right.
So now what does all that mean and how do we apply that? Yeah, I have no idea. Well, let's see what the textbook says. The textbook says the scatter plot of the derivative data, from the derivative plot, we could see that the rate peaks at x equals 20. You can impress your friends with your psychic powers by predicting a shared birthday in a room of 25 people.
I bet psychic
It
is
really
against the
literally
Catholic
says
Church,
that.
so maybe we should get a new one.
Yeah.
What?
I'm pretty sure psychic would probably be against